Okay, we're going to begin our discussion on rational functions. We will continue it tomorrow. Okay, we're going to talk about 3 graphs today, and then we're going to talk about a 4th graph. Well, really kind of 2 types of graphs, and then we're going to talk about another graph tomorrow. Okay, so rational functions. You recognize this graph. Okay, you graphed something like this last year. So I'm going to give you some reminders, we're going to do some practice, and then I'm going to teach you something that happens that you haven't seen before. Okay? So first of all, a rational function can be written in the form polynomial over polynomial. That's why it's in this chapter. Okay? When we have a rational function, we, in this chapter, are focusing on polynomial over polynomial. N for numerator, D for denominator. The numerator and denominator cannot have any factors in common. So if they do, you're going to have to simplify. And that's something we'll talk about at the end of our notes, what happens if we get into that situation. Now, we have not done a lot of discussion on rational functions, but you did, we did talk about the domain of rational functions in chapter 1. What did we look for with the domain when we were in chapter 1? What? What can equal 0? All right, our denominator can equal 0. So our domain will be all real numbers except those x values that make the denominator 0. Okay, that still has not changed. Just a warning, I will be asking for domain and range on each of these graphs. All right, I put that graph up on the first slide, and the first thing your eyes went to were the what? You guys talked about this. The asymptotes, okay? So we need to discuss what it means to be a vertical asymptote, what it means to be a horizontal asymptote, and then we also need to remember how we find them, okay? Like I said, this is something you did last year, but we need some reminders and we need to work on it, all right? So a vertical asymptote is a vertical line where values of our function increase or decrease without bound while approaching it. Okay, so I'll let you write it down and then I'll describe it with a picture. Okay, these occur when the denominator is 0. So if we have a vertical asymptote at x equals a, as our function approaches a, it is going to either increase or decrease without bound as it gets closer and closer to the asymptote. That's what that means. Okay, we're going to approach the asymptote and continue to grow towards infinity as we get closer to it, or fall towards negative infinity as we get closer to it. Will we ever cross the vertical asymptote? No. That is where our function is undefined, which is why it's represented by a vertical line. Okay? Where your denominator is 0, that is where we have our vertical asymptotes. All right, horizontal asymptotes. Okay, let me back up one moment. Is it possible to have more than one vertical asymptote? It is. Okay. However, it is in the rational functions we will work with, we will only see one horizontal asymptote, if at all. There are graphs with more than one horizontal asymptote, but we don't worry about those till calculus. Okay? All right, so a horizontal asymptote is a horizontal line, y equals b, where values of f of x approach b as x reaches infinity or negative infinity. Write it down, and then I'll talk about what that looks like. So a horizontal asymptote. As x reaches infinity, then our y values need to approach the horizontal asymptote. As our x values go towards negative infinity, our y values need to approach the horizontal asymptote. Okay? Can we cross the horizontal asymptote? We can. Let me give you a flashback to Honors Algebra 2. Remember a graph looking like this? If you did graph that in Honors Algebra 2? You did? I'm seeing some head shakes. Okay? It is okay for our graph to cross somewhere in the middle as long as towards infinity and negative infinity we approach the asymptote. It's all about what's happening at the ends of our graph. It's okay to cross the asymptote in the middle. Okay? Now we're not going to see that very often, but I need you to know that it is a possibility. Okay? All right, now, how do we know where our horizontal asymptote is? There are 3 different rules that we're going to talk about, but only 2 of them today. To determine, HA is abbreviation for horizontal asymptote. Are you okay with that? All right, less letters for you to write. We're going to compare the degree of the numerator to the degree of the denominator. Okay, so we compare the polynomials in numerator and denominator. Okay, raise your hand if you think you remember these 2 rules that we're about to go through. Good, okay. Well, this will feel new then, all right. Okay, so like I said, 2 rules today, 1 rule tomorrow. The first rule, if the degree of the numerator is smaller than the degree of the denominator, then your horizontal asymptote is y equals 0. So if your denominator has a larger degree, y equals 0. If the degrees are equal, then we're going to look at the ratio of the leading coefficients. Okay. To give you an example of what that would look like, if this was our rational function, do you notice how the degree of the numerator and denominator are both 2? Okay. Then our horizontal asymptote, we would look at the leading coefficients. Y equals 3 over 2 would be our horizontal asymptote. All right, so today you're going to have to keep these two rules straight. Is our denominator of higher degree? Y equals 0. Are they of equal degree? We look at the leading coefficients. Okay. Now, I'm going to give you some steps for graphing these. Okay. I tried to type them as concise as possible so you don't have to write a lot of stuff down. But I think it is helpful for you to come back to your notes and look at kind of the order in which you should think about things. Okay. So, this is how we're going to graph. First step, you need to factor the numerator and denominator and simplify if it is possible. There will be many times where you cannot simplify, and that is fine. But we need to account for the possibility that we could simplify. So we're going to see if we can. Okay. Also, by factoring, it'll help you identify a couple things. Okay. First thing is I want you to determine and sketch any vertical asymptotes that you have. What do you think comes next? Determine and sketch horizontal asymptotes. Well, and that should just say asymptote. There will always be one. Hey, now your asymptotes should break your graph up into some sections. Okay. Based on where your vertical asymptote is, I'm going to ask you to plug in x's to find coordinates. Okay. I'm going to ask that you have at least 2 points per section to get an idea of the shape. X and Y intercepts could be helpful here. I think your book is going to ask you to find X and Y intercepts. Okay. So what do I mean by 2 points per section? If you have a vertical asymptote, only one, pick 2 points to the right and 2 points to the left so you can get the shape of the two pieces. Okay. When you draw your curve, please make sure it's nice and smooth. Okay, there are no corners. There are no zigzags. It's just nice and smooth. We know that our curve should approach our asymptotes in a certain way. Okay. And then I will be expecting you to tell me the domain and range. Okay. Now, I know you've done a lot of writing, and I apologize for that, but when you are working on your homework both tonight and tomorrow, I think you will appreciate coming back to what you have written down. Or when we are studying for the test next week, it's been a week since you've done this. Okay? So we're going to go through 3 examples. The first example is very basic. It is something that you would have graphed last year, and it shouldn't take us a whole lot of time to do. Okay? That is a very great graph. So f of x is 3 over x minus 2. Can we factor numerator and denominator? No, we don't need to worry about that. All right? Good. So let's worry about our asymptotes. First, let's talk about our vertical asymptote. And I am just going to abbreviate VA and HA. Is that all right with everyone? Okay. So Tiger, where would our vertical asymptote be? Thank you for correcting yourself. X equals 2. I do expect to see the equation of a line. So x equals 2. Okay. Our horizontal asymptotes, or asymptote, excuse me, Lindsay A, where would that be? Let me ask you this. Are the degrees the same, or is the numerator smaller in degree? Okay, so what did we write down if the numerator was smaller?
Equals 0.
Okay, so y equals 0 would be the horizontal asymptote here. Okay. Once you get your asymptotes drawn, it's only a matter of plugging in numbers, okay? You should feel kind of a sigh of relief once you get your asymptotes on there. All right? So this is what I'm going to ask you to do. Just make an XY chart so I can see the points that you have on your graph, okay? And this is what I would do. Our vertical asymptote is at 2. So I'm going to pick 3 and 4 to plug in because they are just to the right of our asymptote. Okay? So Eli, if we plug in 3, what do we get?
3.
What about when we plug in 4?
3x.
Okay, that's 2 points. You're welcome to find another one, but we know what's going to happen. We know that towards the vertical asymptote, we're going to approach it with unbounded behavior, and then towards infinity, we are going to approach that horizontal asymptote. Okay, that's enough for that side of the graph. Let's go to the other side of the vertical asymptote. Since our vertical asymptote is at 2, to the left, we could pick 1 and 0. So Kira, if we plug in 1, what would we get for our y value?
-3.
And what about 0?
-3.
Okay, so 1, -3, and 0, -3/2. Same. Okay, so we have a little bit of symmetry going on. Okay, that is our graph. And that is what I would expect to see. All right, we have asymptotes labeled, we have points labeled in a chart, plotted, all there. Okay, now let's talk about domain and range. Scooch down a little bit so I can write it out. Chris, what do you think about the domain?
I think it's going to be negative infinity 2 with the little connecting and 2 to infinity.
And you know that because?
The vertical asymptote at 2, x equals 2.
Okay, the vertical asymptote is at x equals 2, so we have to exclude it. Okay, very good. Callie, what do you think about the range?
Negative infinity
To what? Well, let's look at the graph. Don't worry about the equation. Let's just focus on the graph. Okay? Where do we have y values, or where do we not have y values? Okay, and why are you saying 0?
because you can go as close to the, if you get as close to 0 as you want, you can get there.
Okay, so we have that horizontal asymptote at 0. Okay, so negative infinity to 0 and 0 to infinity. Okay, we have y values everywhere except that horizontal asymptote. So we have to exclude 0 from our range. Okay. All right, that was a nice warm-up. Okay, does that bring back memories from last year? A little bit for a couple of you. Okay, now that's probably as basic as you're going to see. Okay, so we're going to go to a little bit more complicated example, and then I'm going to introduce you to a new topic, I guess you could say. All right, 2x squared over x squared minus 1 is our next example. All right, our first step is to factor. 2x squared we're going to leave in the numerator, but what can we do with the denominator? Anything? Okay, we don't have anything that can reduce, but it'd be best to refer to this for any for identifying coordinates and vertical asymptotes, that kind of thing. All right, so vertical asymptote. Caleb, what do you think?
Be anything but negative 1 and 1.
Okay, so you're describing to me the domain, so we'll get to that. So since 1 and negative 1, you're saying they're making our denominator 0? Okay, so our vertical asymptotes would be at 1 and negative 1. Okay, good. Now, I'm going to go ahead and count by 1/2, just so we can get everything fit on here, okay? Okay, Marissa, how about you help me out with the horizontal asymptote? Is it y equals 2, she asks. Anybody give her an answer? I'm seeing some nods. Okay, we have And it's easier to look at this one up here, right? The degrees of the numerator and denominator are the same, so we're looking at those coefficients, 2 over 1. Okay? So I'm counting by 1/2, remember, so y equals 2 would be right here. Okay? All right. Now we got to figure out what our curve looks like. Okay? Now, how many sections of the graph do we have? Okay, well, technically, yes, 6. Okay. But if we look at our vertical asymptotes, we have like 3 different parts we're going to have to look at. Okay? So, let me remind you that on the test, I'm not going to allow a graphing calculator because I want you to come up with these graphs on your own. All right? So let's practice without our calculator. Okay? Let's go ahead and figure out what's happening on the right and left. Okay? So since we have this asymptote at 1, what would be nice numbers to plug in? 2 and 3. Okay? So when we plug in 2, what are we going to get? 8/3. Okay. So 2. 8/3. And when we plug in 3, we're getting 9 times 2 upstairs and 9 minus 1 downstairs. What is it? 18/8, which would reduce to 9/4. Okay, remember I'm counting by 1/2, which is why I placed those coordinates where I did. Okay, let's go to the very left side of the graph now. Okay, it's okay that you don't go in order. Okay, we plugged in values to the right of the asymptote. Let's go to the left of the asymptote. -2 and -3. What do we get there?
It would be 8/3 and 9/4.
Uh-huh. When we're plugging into x, it's x squared, right? So we're getting the same values there. Okay? Now, we have to figure out what is going on in between the asymptotes. I will tell you that when you have a graph with more than one vertical asymptote, when you're looking at coordinates in between, you're going to want to plug in more than 2 values. Okay? You're going to have one of 2 options. Okay? Do you remember that graph I showed you on like one of the first slides where it was like a snake through the middle? Right? That could happen, or we could get a situation like this. All right? Let's go smack dab in the middle. What do we get when we plug in 0?
0.
We get 0. Okay? Then we're going to have to figure out what's happening to the right and left of 0. So what do we get when we plug in 1/2? What are you getting?
-3/4 or 2/4.
Not quite. In the numerator, you should get 2 or 1. You have 1/2.
6/4, -6/4.
Keep working. Keep working. He's not the only one who should be figuring this out.
Oh, we're on positive 1/2.
Yeah. Should be 1/2 over negative 3/4, right? And what is 1/2 divided by negative 3/4?
Negative 2/3.
Okay, when we plug in negative 1/2, we also get negative 2/3. So we have this happening. It's kind of interesting, isn't it? Okay, I will tell you, when you have two vertical asymptotes, you're going to get something that looks like this, or something that looks like what we talked about right here. Okay, now let's talk about the domain and range for the problem that we just did. Okay, if we're talking about the domain, all right, we have two vertical asymptotes that we have to exclude. So we would write our domain like this: negative infinity to negative 1, negative 1 to 1, 1 to infinity. Okay? Now, our range becomes very interesting with this problem. It's not a matter of just excluding the horizontal asymptote. All right? Now, we have y values above the horizontal asymptote, but we have like this blank space right here. Do you agree? In terms of y values. So if we go from the bottom up, we have y values from negative infinity, but then they stop at and including 0, okay, because there is a coordinate there. But then we have a blank space, and we have values above our horizontal asymptote, but they're approaching it, so we can't include 2. All right. Gotta get through this example right now. Okay, our first step is to factor. Numerator factors to what? X plus 2 times x minus 1. Our denominator factors to x plus 2, x minus 3. We get factors that cancel. Okay, so here's something new and exciting. All right, we have factors that cancel. When we have factors that cancel, it means that there is going to be a hole at the x value that you just canceled out. Okay. Do you remember when we talked about like open circles, closed circles, right? Open circle, we consider a hole. So when we cancel out factors, we are going to get a hole there. So let's go back to our example. Now that we've reduced, we have x minus 1 over x minus 3. If we talk about vertical asymptote, our denominator is 0 at 3. So x equals 3 is our vertical asymptote. Okay. The degrees of the numerator and denominator are the same. So we look at the leading coefficients. We have 1 over 1. So our horizontal asymptote is 1. Okay. So, same process. We're plugging in 2 to the right, 2 to the left. Our vertical asymptote is at 3, so we're going to plug in 4 and 5. However, I want you to plug into the simplified version. It's less to think about, okay? We simplified for a reason. So if we plug in 4 minus 1 over 4 minus 3 would give us 3. When we plug in 5, we would get 2. Same thing to the left. We're going to plug in, what sounds good, 2 and 1. All right. When we plug into x minus 1 over x minus 3, we get, when we plug 2 in, we get negative 1. And when we plug in 1, oh, that's nice, we get 0. Okay, now here's the kicker. We got to plot the whole. We canceled the factor of x plus 2, which means we have a whole at negative 2. X plus 2 is the factor we canceled. Negative 2 is where the whole is. You have to go back to this simplified version. When we plug in negative 2, we get negative 3 over negative 5. So at negative 2 3/5, we have a whole. Pretty cool, right? It looks like the graph x minus 1 over x minus 3, but there is a whole at negative 2 since we canceled out x plus 2. Okay. So, let's talk about how this affects our domain and range quickly. Our domain, we have a whole where there's no x value, and we have a vertical asymptote. So in our domain, we have to exclude the whole and the vertical asymptote. Same thing is true for the range. We do not have a y value at the whole. So our range, we have to exclude 3/5 because it's the whole. And we don't cross the horizontal asymptote, so we have to exclude 1 as well. All right, you have a book assignment. It is very important that you do these problems, especially the ones that have holes. That's the new thing today that I taught you. You need to practice it. Okay? Tomorrow, we're going to go over your homework, and then we are going to talk about what happens when our numerator has a larger degree than the denominator.